Hi, welcome to the hy-fcell in Stuttgart and to H2 International Video Studio. I am very excited and happy to have here Dr. Dimitrios Dimitrakis. He's a coordinator of the EU project hy-fcell-Award, and he is also the group leader in the Institute of Future Fuels at the DLR, Deutsches Zentrums für Luft und Raumfahrt. Welcome.
Thank you very much. I'm very, very happy to be here.
Yes, and the reason you're here is, I can already say it, you won a hy-fcell-Award for a very special type of electrolysis. It's called, I've got to look, it's sulfur dioxide depolarized electrolysis. Luckily, there's a short word, SDE.
Correct.
Can you explain what that is?
Yes. First of all, let me say how happy I am, and of course the group as well, the team, to receive this award. The SDE, let's say, is a special kind of electrolysis. It works similar to the PEM, water electrolysis. The difference is that we are, besides water, also pumping in the SO2, the sulfur dioxide molecule. And this allows us to generate, instead of oxygen, it allows us to generate sulfuric acid. Mm-hmm. And on the other side, as in water electrolysis, hydrogen. Now, this makes sense because it requires much less electricity compared to the traditional or conventional PM water electrolysis. This is no surprise because we are pumping chemical energy into the system via this SO2 molecule. There are challenges, but this is a significant step forward to really lowering the energy demand.
Mm-hmm. So chemical energy, like the SO2 molecule, already has a higher level of energy than the water you would normally put in.
It's easier to use this molecule and generate hydrogen, sulfuric acid, than in the traditional water electrolysis to generate hydrogen and oxygen.
Mm-hmm. And where do you get this SO2 from? Very
good question. Now, this is exactly the most important point. So, as mentioned, this is we expect that we have a lower energy consumption, and the key here is where do you get this SO2 from? So within this project, the hy-fcell-Award project, we are getting the SO2 from the first step of the process, which is sulfuric acid splitting. We can do this using renewable energy with power from the sun. We split sulfuric acid, we create SO2 gas, and then we use this in the second step of the process in the SDE to generate hydrogen and sulfuric acid, which we can then recirculate. However, this SDE step can be also a standalone technology, depending on where we get this SO2 molecules, this SO2 gas from.
Where would that be? Where is it? Anywhere as a waste product?
Exactly. And this is what makes this technology so interesting. We are not only in the hydrogen market now, but we are very much looking into the sulfuric acid industry, in the mining industry, the spent sulfuric acid recycling industry, in the fertilizer industry. So there is a very, very big market that has this molecule, that has these streams available, either as an intermediate product ready to be used or sold, or what we are even more specifically looking at, internal to the industry, waste streams containing this SO2, where we could really put our SD technology in as a standalone technology, make use of this SO2 molecule, and generate at a much lower electricity cost the hydrogen, which is definitely a valuable product, and the second, also very valuable product in this industry, sulfuric acid.
So they have a chemical they want to get rid of that tends to create acids, and it is something you want to dispose of, and you can use it to make hydrogen of it.
Exactly. There are waste streams containing this SO2 that we are looking to valorize using this technology.
Okay. Could you even take it out of the power plant if they for cleaning, air cleaning?
Say again?
If you have a power plant that leaves out SO2 where you need the cleaning, could you even take it out of there?
I mean, it's definitely an interesting idea. We have not actively looked into separating SO2 from other gases, yet still we are focusing on specifically already existing available, mainly waste streams where we can take it as is and use it in our process.
Okay. And the European Commission already listed your technology as market ready, and it's a word that always a bit difficult to understand when it stands on an innovation radar. So does it mean I can just go and buy it like this year or next year, or what's where are you with it?
Very, very nice. Yeah. Let me first say that we were really happy to be classified as market ready. This was done from the experts of the European Commission through the Innovation Radar in the framework of the EU hy-fcell project funded by the EU. So what this means is that this really solidifies our position into taking the next steps towards commercializing. So what we are really looking right now, we are in discussions with the industry to exactly determine this markets where this technology can be applied, develop the relevant figures, and most important step, develop the pilot plan to actually demonstrate this technology in the relevant environment.
And will the pilot plant be the thing when you get more information about the cost efficiency, or can you already tell a bit about it?
I can tell some, let's say, key figures that we have right now. So on purpose to be comparable to the water electrolysis technology, we are focusing on the hydrogen production cost. So right now I can tell you that we are achieving around 40 kilowatt hours of electricity required to generate 1 kilogram of hydrogen, which is already beneath the target for water electrolysis at 50. So we're quite happy and successful there. And this is not even including any cost benefits we would have from actually the selling or the further production of the sulfuric acid, which is our next product.
So you're specifying like one important part of the cost, which is the electricity, and there's also the other part, which is the investment. Do you have any relation I know it's very new, but just from the components and the things you need, where would it be placed?
Well, it's a bit too early to say because this is exactly the matter of discussion right now with the industrial players. So at this moment, I would prefer not to discuss.
Okay. So speaking of the pilot plant and the next step, so what do you think will happen like until next year or until the next 2 years?
Yes. So right now we are in discussions with the chemical industry, mainly the German and the regional industry we have, and to see what our goal is to really show operation of this pilot in the relevant environment. This is very important. Set up the pilot in an industrial complex where we can really make use of the existing streams available, and also to where we will supply our products.
Okay.
So it's a matter of negotiations happening right now, discussions with key players in these areas.
And if all goes well, so next year you will tell us where you built the plant.
Exactly. And we are very much focused and looking, and there is a lot of support from DLR in this direction to looking into the next step for really commercializing this technology. Seeing about startups and all necessary steps in this direction.
Okay. Yeah, so I would really love to see you again and interview about the pilot plant or the first plant in real life sold to a customer.
Thank you so much. I'm really looking forward to being here next time and really showing the pilot plant in the background behind me.
Yeah, thanks.
Thank you.